For our final lesson in this factoring unit, the objective that you're writing down is I will be able to factor trinomials with a leading coefficient that is greater than 1. What you need to notice in every example you're going to see today, the A, remember this is A, this is B, and this is C, your A term is going to be greater than 1. It's not just x squared plus 5x minus 2. There's actually a coefficient attached to the x squared besides 1. That means our process changes slightly. You're going to want to pause the video and write these steps down. Once you have the steps written, we're going to just practice, practice, and practice, and these steps will make sense. The first thing we're going to do, just like before when A was 1, we're going to multiply the terms A and C, the numbers. We will then find the two numbers that multiply to A times C that will add to our middle term, just B. Then we're going to rewrite the trinomial, breaking that middle term into two like terms. And that'll make sense, I promise, as soon as I show you. The next step we'll do from a previous lesson is we're going to group the first two terms, and then we'll group the second two terms. We'll pull out the GCFs for each one and write what's left over. We can then distribute to check our answer. Take a moment, pause the video so that you have all of those steps written down. Move on only when you're ready. Alright, here's the first example. We're going to go kind of slow, and I'm actually going to show you two different ways to solve this problem. The first thing we need to do is we need to find two numbers that will multiply to A times C. Remember, A, B, and C. Well, A times C is 30. I need two numbers that multiply to 30. Those same two numbers must add to negative 11. That's the B term, negative 11. Well, the ways to multiply to 30 are 1 and 30, 2 and 15, 3 and 10. I need to find a way that have two numbers that will add to 11. One last pair we forgot was 5 times 6 is 30. 5 and 6 are the two numbers that we need. But in order to add to a negative 11, both of them need to be negative. Negative 5 times negative 6 does equal negative 30. So these two numbers that we just found, negative 5 and negative 6, are very, very important. That's not our final answer. We cannot just say the answer is x minus 5 times x minus 6. Because if I go to multiply to check my answer, x times x is x squared. That is not 5x squared. It's missing the 5. So the process that we've learned previously is not going to work today. We have to add a few extra steps in there because A is greater than 1. So here's what we're going to do. I'm going to show you two ways. We're going to take this exact trinomial, 5x squared minus 11x plus 6. Instead of 11x, I'm going to rewrite it. I don't want to call it negative 11x. I'm going to use these two numbers I found. Instead of negative 11, I'm going to write it as negative 5x and negative 6x. That should make sense because negative 5 and negative 6 does equal negative 11. It's just breaking it into two separate terms. Now don't forget this plus 6 on the end. So the only thing we've done so far is taken that negative 11 and we've broken it into two separate terms, negative 5 and negative 6. The reason we've done that is now we can group the first two and we can group the second two. Once we have 4 terms, we can group them just like we did 2 lessons ago. So let's look at that first pair. The greatest common factor that goes into both of those terms is 5x. That leaves me with x minus 1. I know quickly if I double check myself and distribute, I will get back to the original 2 terms. Looking in green parentheses, the biggest number that goes into 6 is 6. And I'm going to pull out a negative 6. The reason is when I do my parentheses, I need it to match what's in my yellow parentheses. So the only way to get a positive x here to match this yellow positive x is to pull out a negative 6. So that when I multiply, that does get me back to negative 6. And I would multiply this by a negative 1, because a negative times a negative is a positive 6. Notice they both share a factor of x minus 1. So that is the greatest common factor. And what remains is the 5x and the minus 6. I'd like you to pause for a moment and see if that makes sense. That's a lot of work and it's a lot of new things. If I were to double check to prove that I did in fact do it correctly, I could distribute. X times 5x is 5x squared. X times minus 6 is minus 6x. Negative 1 times 5x is minus 5x. Negative 1 times negative 6 is positive 6. If I combine my like terms in the middle, I do in fact get back to the original trinomial that we started with. So take a moment, let that sink in, possibly re-watch the problem, but I would also like to challenge you. I'm going to show you a completely different way to do the exact same problem. It's the same steps, but it's a different way of organizing your material. So I'm going to very quickly erase this so we can see. We're going to go back to that box method or the Punnett squares that we used when we multiplied. We are going to draw our 2 by 2 square. The difference is, instead of knowing what the things are on the outside and then multiplying to fill in the inside, what we're going to do is fill in the inside and then factor the outside. Find out what the greatest common factors are. So here's how this goes. The first term, whoops, I hit the back arrow a few too many times. Give me just a moment, sorry about that. All right, drawing the 2 by 2 square. Here's what you're going to hear me say over and over again. First term goes in the first box. Last term goes in the last box. What we have to figure out now is what 2 numbers could possibly go in the other 2 boxes. If you remember from when we multiplied, these 2 terms here are going to be like terms that add up to negative 11. Oh, well, we found those numbers over here. It was minus 5 and minus 6. So we're going to write it as like terms, minus 5x, minus 6x. If I were to add them up, it does in fact equal negative 11x. So that's how we fill in the 4 squares. Remember in yellow, first term, first box, last term, last box, and then the 2 terms in the middle are from the work we did over here, but we write them as negative 5x and negative 6x. Now here's where this gets interesting. You're going to look at the top row and ask yourself, what do these share in common? What is the greatest common factor of these 2? They both share a 5 and they both have an x. Look at this row. They both have a 6. That's it, because the yellow 6 does not have an x. Now, we're going to look vertically up and down. Kind of different here. What do these two terms share in common? Well, 5 and 6, they don't share anything, but they do both have an x. Looking at this one vertically, 5 and 6 again don't share anything, and they don't have an x that they share. So the only number that can go into 5, that can go into 6, is 1. That's it. It's relatively prime. They don't share anything other than 1. The only thing we have to check now is make sure that our signs match. Now you take the outside Punnett squares and you check your signs. So if we were to do 5x times x, that does equal 5x squared. Well, 5x times 1 does not equal a negative 5x squared. But if I make the 1 a negative 1, now it does work. Well, let's finish checking. X times 6 is not negative 6x. The 6 would need to be negative. So x times negative 6 is negative 6x. Negative 6 times negative 1 is a positive 6. So here's what's interesting. On the outside, we have an x and a minus 1. And then going out the outside in green, we have a 5x and a minus 6. And that is exactly the answer we got when we did it last time. I know that was a lot of work. I'm going to alternate problems showing both methods, and then you decide by the end of the notes which method you prefer. So for this example, I'm just going to do it the one way. We need to find two numbers that multiply to a times c, which is 16. Those same two numbers must add to 17. If you are an X person, you're doing this. 2 that multiply to 16 that add to 17. Well, the two numbers would be 1 and 16, because 1 times 16 is 16, 1 plus 16 is 17. So I'm going to take this trinomial, and instead of 17x, I'm going to break it into those two terms I just found, 1x and 16x. Because 1 plus 16 is just another way to write 17. Now I'm going to group the first two, and I'm going to group the second two, pull out what they share in common in red parentheses. They both only share an x. The biggest number that goes into 2 that goes into 1 is just 1. And what remains is 2x plus 1. In my gray parentheses, the greatest number that goes into 16 and 8 is 8, a positive 8. That leaves me with 2x plus 1. Notice in parentheses, the 2x plus 1 has duplicated, so that is my common factor. Remaining is my x and my plus 8. That's it. On the next example, I'll do the box method, and you can decide which one you like better. So here we go. We are going to set up our box. First term, first box. Last term, last box. What I have to do now is find the two like terms that will add up to the 4x. So I need two numbers that multiply to a times c, which is 3 times negative 20, which is negative 60. Those same two numbers must add to b, which is 4. So I've got to think of numbers that multiply to 60. I'm thinking 6 and 10, but let's see if I can make that work. In order to add to a positive 4, the 6 would have to be negative. Well, that works. Negative 6 times 10 is negative 60. Negative 6 plus 10 is positive 4. So I just found a negative 6 and a positive 10. But remember, these must add to the like terms of 4x. So don't forget the x's. Now, we're going to pull the greatest common factor across both rows? Well, 3 goes into 3 and 6, and they both have an x. 10 is the greatest number that goes into both of these. They do not both have x's, so there's no x to pull out. Now we're going to go vertically. The only thing these two boxes have in common is their x. And the biggest number that goes into 6 and 20 is 2. Double check the signs. 3x times x is 3x squared. But 3x times 2 is not negative 6. So I'm going to make the 2 negative. Now when I multiply, that matches. 10 times x is 10x. Negative 2 times 10 is negative 20. We have found our two factors. In red, we have 3x plus 10 that we pulled out. Up above, we have x minus 2. So when we factor the trinomial, the two factors are 3x plus 10 and x minus 2. So now that you've kind of seen it a couple times now, do you feel like you're more of a factor by grouping person, meaning you have 4 terms and you group? Or are you more of a box person when it comes to factoring? I'd like you to kind of make that decision and then go ahead and start this next problem. One thing I would like to point out, and I'm hoping that maybe somebody noticed this, do you notice that all of the numbers are divisible by 3? That means we can pull a 3 out of all of these. That would leave me with x squared plus 4x plus 3. Notice the leading coefficient is a 1. The reason that is very, very exciting is we now need two numbers that multiply to 3 that add to 4. Well, that's just 1 and 3. So because a is 1, we can simply write x plus 1 and x plus 3. And we're done factoring. They all happen to share a factor of 3. Now for the next one, 6, 7, and 2 do not share a factor. So I want you to pick. Are you a box person or are you a factor by grouping person? Pick your method, work it through, and then check your answer. No matter which method you chose, did you come up with the two factors of 3p plus 2 times 2p plus 1? If you did not, take a moment, check my work, and see if you can find any mistakes. Remember, first term went in the first box, last term went in the last box, and the way I found my two green terms is I needed to find two numbers that multiplied to a times c, which is 12, that added to b, which is 7. That's 3 and 4. So in green, I wrote my 3p and my 4p. Doesn't matter which one you put which. You could put them in either order. You will still find the same greatest common factors. And then I looked at both rows and both columns to find the common factors in red. If you feel comfortable, go ahead and try this last problem for your notes with whichever method you are most comfortable. For that final example, I decided to do factor by grouping. Take a moment, check to see if you got to the correct factors of 4m minus 1 and m plus 4. If you did not, please take a moment to look at my work, and whether you did it by grouping or by the box, you should still end up in the same two factors. If I had followed and put the first term in the first box and the last term in the last box, and then those two numbers that we found, I would still find the same factors. This shares a factor of m. This shares a factor of 4m, or excuse me, 4, because this was 16m. And then if I go straight up, I would find 4m is what they share, and just a minus 1 is what they share. Notice that matches 4m minus 1 and n plus 4. When you feel comfortable with this process, you are done. You are ready to complete your notes and move on to your assignment.